In this video we're going to start to explore tree diagrams. A tree diagram is basically a really visual way of mapping out all of the outcomes of some different events. So in this particular example we're talking about the probability that a player scores a penalty in a particular game of football. So the probability that Ruben scores a penalty in a game of football, 2/3. He takes 2 penalties in a match. Draw a tree diagram to show this information. So the very first thing we need to think about is what can happen here. So there are 2 options. We can either get score or Ruben can miss. Now the probability he scores is 2/3 and the probability he misses must be 1/3. So he takes 2 penalties. This is only accounted for the first penalty. So I'm going to label this as first there. Now assuming he scores the first one, I travel along this branch and then I get to the second penalty. Again, 2 things can happen here. He can score or he can miss. Now the probability he scores is unaffected, so it's still 2/3, and the probability he misses is still 1/3. If we look down here at this branch, if he missed the first penalty, there's a second penalty, and again 2 things can happen. He can score or he can miss. The probability he scores is 2/3, probability he misses is 1/3. And let's just label this second. So what this tree diagram does is it maps out all of the things that can happen. So the end of this branch is what happens if he scores, then scores misses, misses scores, and misses, and then misses again. So moving along these branches, what this means is the probability he scores the first one and he scores the second one. And is a key word in probability. Whenever we do an and rule, it means we multiply. So what I'm going to do here is the probability he scores times the probability he scores. This is going to give me 4 out of 9. So the probability he scores both penalties is 4 out of 9. The probability he scores then misses, I'm going to travel along this branch, so the probability is 2/3, and then along this one times 1/3. So 2/3 times 1/3. And when I multiply these together I get 2/9. So I'm going to continue this for the other branches in my tree diagram. Going along this one, he misses, then he scores. It's 1/3 multiplied by 2/3, and that's 2 out of 9. And the probability of a miss and a miss is 1/3 times 1/3, which is 1/9. Now a little tip with tree diagrams, I wouldn't simplify at any point until I need to give a final answer. So all of these are left exactly how they look on my tree diagram. If this was 4 out of 6, I would keep it as 4 out of 6. So looking at this, let's look at the next questions. What is the probability he misses both? Well, I can see from my tree diagram, moving along this branch, miss, and then along this branch, miss again. I've got the probability of that as 1/9. And the probability he scores only 1 penalty, this is a little bit more complicated. There are 2 possible routes to take where he scores only 1 penalty. There's this first one where he scores the first penalty and then misses the second, and there's this one where he misses and scores the second. So 2 things can happen. Either he scores and misses, or he misses first and then scores. Now in probability, when we come across the word or, this means that we add probabilities together. So 2/9 add 2/9 gives me my answer to this part, 4/9. In this question, it talks about the probability of rain on 2 consecutive days, so Saturdays and Sundays. So what we're going to do first is set up our tree diagram. And be careful with questions like this. Read them very carefully. You might be tempted to put 2/5 here and 9/10 here. It doesn't work like that. The first thing that can happen is on a Saturday, and it's either going to rain or it's going to stay dry. Now the probability it rains on Saturday is 2/5. This means that the probability it stays dry must be 3/5. So these are my 2 branches showing my 2 possible outcomes for Saturday. Now I'm going to move on to Sunday. On Sunday, 2 things can happen. It can either rain or it can stay dry. And this can happen regardless of whether it rained or was dry on Saturday. So I set up my options like this. On Sunday, the probability it rains is 9 out of 10. So that means the probability it's dry is 1 out of 10. And I'm going to add these on to my bottom two branches as well. Okay. Now what I'm going to do is I'm just going to summarize the end of these branches. This is the probability of rain and rain. This is the probability of rain and dry. This is the probability of dry first and then rain. And this one is the probability of dry followed by another dry day. So let's look at the questions. What is the probability it rains both days? So we can see from our tree diagram there is only one journey I can take, rain and rain. It takes me up to here where it rains both days. So what I've got is rain on Saturday and rain on Sunday. Now remember from the previous example, when I say and in probability it means multiply. So the probabilities here are 2/5 and, so I times 9 over 10. This is going to give me 18 over 50, which is the answer to question number 2. Question number 3, what is the probability that it rains on one day only? Well, there are actually two possible outcomes where this is true. There's the chance that it rains first and then is dry, or is dry first and then rains. Notice the key word in that sentence, or. In this case what we do is we're going to add these probabilities once we've calculated them. So let's work out the probability that it rains and then it's dry. I'm going to do 2/5 and I'm going to multiply that by 1/10. This is going to give me 2 out of 50. Looking at the other options, the probability it's dry first is 3/5 and the probability that it rains following that is 9 over 10. This gives me an overall probability of 27 over 50. Now what we're looking at is either it's raining then dry, or it's dry and then rainy. So what we do is we add these two together to get a final answer of 29 over 50 for the probability it rains on just one day. Here's a tree diagram to have a go at yourself. Take care with this one, lay it out, give yourself plenty of room to show all of your branches. When you're ready for some answers, hit play and I'll show you my example. Okay, the way to set this one up then is, first of all, Ben takes his first pick, and a couple of things can happen. He can either get a red ball or a blue ball out of the bag. Then he has a second pick, and again a couple of things can happen. He can either get a red ball or a blue ball, a red ball or a blue ball. Now the important thing in this question, and it will state this very carefully, is he puts it back in the bag. So at no point will my probabilities change. The probability he picks out a red ball first of all is 3, because it tells me in the question, out of 7, because it tells me there are 7 balls in total. So the probability of blue is 4 out of 7. And I can add these probabilities in along my tree diagram. 3 out of 7, 4 out of 7, 3 out of 7, 4 out of 7. So that's the first part of the question done. What is the probability of getting a red ball twice? So if I follow my branches, the only way that happens is if I go along this one and then go along this one. So red, red. Probability of red and another red. So if you remember, we multiply these two together. So 3 over 7 times 3 over 7 gives me an answer to this one of 9 over 49. And that's the answer to question number 2. Question number 3, what is the probability of getting the same coloured ball? Well, this can happen twice. I can either get red and red, or I can get blue and blue. So let's work out the probability of blue and blue. This is going to be 4/7 times 4/7, which is 16 over 49. Now, two things can happen. Either I get red, red, or I get blue, blue. Both of those outcomes fulfill the criteria in this question. The key word there was or, and if you remember from the previous examples, or means that I need to add the fractions together. So 16 over 49 plus 9 over 49 gives me a final answer for this one of 29 over 49. And that's the answer to the third part. Well done if you got this question fully correct. Consider moving on to tree diagrams number 2. Thanks for listening.